Great. So if I want to ask you guys what this video define NAP, Network Access Protection, what do you think that board mentioned? Based on health check, and that health check is various from one system to other. Let's say in this quick presentation, I will just review what Paul mentioned about network access protection. Yes, it is a Microsoft technology, and let's say it's a Microsoft technique to identify, let's say, the access of a computer, and to identify that access based on an agent who are that agent who is attached to the computer system that one access. So let's say again, and sorry about my voice because I'm losing my voice, but that's fine. Network access protection is a Windows system, and it, as Paul mentioned, it started in Windows Server 2008 or later. It's also the main role of Windows Server 2012 release 2 or version 2, and Windows Server 2016. These servers are equipped with a technology that allow and deny computers from accessing the network based on a number of health checks. And Paul already mentioned some of these health checks in the video. The health check might be, let's say, an antivirus, a service pack up to date, a firewall enabled, or any other health check that are performed and agreed by the NAP server. Also, Paul, in this video, let's say, explain the main two components of any network access protection. Can anybody mention these two components, please? That it must be exist in the NAP architecture. Yeah. These are components. Yeah, it basically, we will come and see some figures that show the NAP components, but the main components is the NAP agent, which is installed on the computer system who want to access the network, and the NAP enforcement point, and the NAP server, or the NAP policy server, or health policy server, as Paul mentioned in his video. So these are really the main components of the NAP. So if we want to define, let's say, NAP again, so a NAP is a network access protection founded in Windows Server 2008 or later. This Windows system, or this Windows policy, allow or prevent a computer from accessing a network based on a number of health checks. These health checks based to protect the whole network. So basically, as you can see in this let's say slide, in 2003, Windows Server 2003, the NAP was called Network Access Quarantine Control. And they distinguish that later by network access protection, just to let you distinguish between the NAP and the network access control. As we have seen in last lecture, that network access control also has a quarantine network. So in 2003, they used NAC, and I can tell, as Paul said, that there's a slight difference between NAP and NAC. NAC is mainly a very general item in security, and network access control, as we discussed last time, it could be agent or agentless, while network access protection is always an agent protection technique. So it's based on agent that is installed on the computer system. Again, guys, sorry about my voice, but it's just started today like this, but I hope that it's clear. So the main identity or the main goal of having NAP is to protect the integrity of your network, especially in organization networks, especially in institution networks, by performing some of these health checks. And these health checks, as we mentioned before, it could be checked that the Windows or the operating system is up to date and all the service packs are installed, or the antivirus has the latest antivirus or the virus has the latest virus definition, or also it has a firewall enabled on these clients. So if after performing this health check, if some of these health checks are failed, the NAP or the network access enforcement point can isolate any of these computers if they are failing the health check. Otherwise, they can send it to some part of the network where they can get the update and allow them to pass the health check later. So we will see the three main option if a computer agent want to access the network. Right. There's a huge problem with NAP, that it does not protect against malicious user. So for example, if an employee want to access the network, he can still pass all the health checks and get in to the production network and execute any malicious software or attack any of the existing server after getting the access. So it does not protect against malicious user, but it's also give the right access to the right PC or to the right client. Okay. Here in that figure, I do have some of the enforcement points, and to be honest, these are the 5 enforcement points that we could have in the NAP process. Let's say here we have a client, and when we see an extreme client, that means that a client with updated antivirus, with updated, let's say, all service packs are updated, and also the firewall are enabled, and so on. So this is an extreme client who can pass all the health checks, and then we have many kinds of NAP enforcement points that we could have. One of these, let's say, NAP enforcement point is DHCP server. I guess most of you know what does DHCP server means. So if anybody can answer this and let us know what is DHCP. So DHCP server is, let's say, the main server. In each network, we do have a server who's responsible of distributing the identity of each host. In order to get receive messages inside the network and send requests or receive response in any network, you have to be identified in that network. And in order to be identified, you have to obtain an IP address from the DHCP server, which means that the DHCP server is responsible about distributing the IP addresses among the clients. And also the DHCP server can distribute these IP addresses among groups. So for example, if we have, let's say, a DHCP server can be configured to give a certain range of IP addresses for some clients and another range of IP addresses for other clients. So when we say that DHCP server is an enforcement point for network access protection, that means the network, the DHCP can perform some of these health checks that are required for network access protection. If that client passes all the health checks, then the DHCP can give that client an IP address with full access to the whole network. Otherwise, that DHCP will only provide the client with an IP address that has a limited access to the network resources. So, for example, if we have, let's say, a client without an updated operating system, or without an updated antivirus, or without a firewall enabled, then we can get that client with an IP address with a limited access to get this stuff updated, or to let the administrator works on your firewall and get it enabled. So this is mainly the enforcement point. And I do want to explain what does enforcement point mean. Does anybody can tell me, let's say, what do we mean by network access protection enforcement point? What does enforcement point mean after I explain the DHCP server as enforcement point? True. So enforcement point, it's true. It's an entity, let's say an entity inside the network where you can control who can access your network. So enforcement mean how do you want to control your network? That's why it's called enforcement points. And points, it's the point where you can perform the access check or the access control check. So again, DHCP can check and then distribute the IP address based on the result of the health check. And also the VPN server. Do you know what's VPN? Again, guys, VPN server, virtual private network. So VPN mechanism or VPN technology is allowing to have a private network over the public network. For example, if we have here a MEU network on campus, and there is a client or an employee or a student who want to access this network at campus, as they are in the campus while they are not in the campus, then they should use one of the VPN technology, such as the tunneling one, which means that we are using technology to encrypt all the packets come from outside and deal with it as it's inside. So that's really a virtual private network. And again, if we want to say a virtual private network as enforcement point, then again, before getting access to the local network as a virtual network to treat with that client, we need to do the health check again. And if that client passes all the health check, then he can use the internal network as a client inside that network. Otherwise, that network will be treated and sent to another network, not to the production network. So this is mainly a virtual private network as enforcement point. And also, if you are using 802.1x that we explained before, the network access control, the 802.1x is the protocol that are used with the switching, where you can determine which port you can give it to any client. So again, all the network components with the 802.1x technology, they can be also an enforcement point. So that switch or that network device can perform the health check on the client, and based on that health check, they can distribute the ports among these clients. Also, the terminal service gateway, the gateway which is identify or which is allow all the terminal service to connect to the internal servers. They can also be enforcement points and do the health check. And the last one is the IP security. And when we are talking about IP security, we will see a figure in a bit that show that IP security means that all the traffic come to that network should be encrypted and should be authenticated. And if we can see the next figure, I will come back in a bit for this, but if we can see, not that figure, yes, this figure. In this figure, there's an app network layout, which means that if a client wanna access the production network, which is the real network, the one in the top, then they have to provide an app support, and they have also to do and the NAP server or the NAP enforcement point should perform the health check for that client. And we have two different also two another networks, which is the remediation network that we are using to keep that client updated and perform some more health checks on that client. While if that client, for example, does not support an app, and as a client does not have the agent, the NAP agent, to be connected with the NAP server, then they can go to the guest network. So these three kind of network, it might be sometimes exist in one physical location, and that means that we should use IB security in order to distinguish the traffic between these three kinds of networks. So that's why IB security is important as enforcement point to distinguish between the client that is extreme client with a full health check and the other client without or the unhealthy client. So here we have the four main types of enforcement. We are missing only the terminal one, but it's fine. So the DHCP, if and a client with a healthy report come, so the DHCP will give it an IP address with full access. So full IP address given with full access. If it's not healthy or unhealthy client, then it will be given a restricted IP address with a restricted set of routes and restricted access as well. While the VPN, if they are a healthy client, they can get a full access to all the server inside the local network. Otherwise, it will be a restricted VLANs. In 802, again, it's a physical type of virtualization based on the switching and based on distributing ports among the clients. So if these clients have a full healthy check, then they can get a port on that switch with full access. Otherwise, these switches will give that client a port that only connect with a restricted type of LAN or VLAN based on the architecture of that network. In IB security, as we mentioned before, all the traffic is encrypted. So with a healthy client, that client can connect with any other devices inside the network using the full encryption and using the full detail of the authentication and authorization. While in IP security, if the unhealthy client, it will be rejected and it will not be allowed to enter the internal network. So we don't have in the IP security any kind of remediation or any kind of quarantine devices. Right. So we have done with these 4 types or 5 types of NAP enforcements and what they should do. So if a computer fails the health check, we have only 3 situations. And these are only the 3 situations that we should use. So the first one, do nothing. That's mean if a client failed the health check, and for example, it does not have updated antivirus. So in some network where NAB is not implemented and NAB is not really controlling the access of the internal network, so they do nothing and they only keep a log file of the clients, and if they are failed the health check or they are not, and that's one kind of networks. The other kind of the network, they deny access of that client from accessing any resource inside the network, and that's the other side of the solutions. And the third one, they only grant access to a remediation network where they can update and pass the health check later on. So these are the only three possible, or the only three solution that we might have after a computer fails the health check. Right? Next slide. It's freezing. Right. So NAP component, as we mentioned before, and I guess guys mentioned that, we have the system health agent, and they call it sometimes SHA. That SHA is the agent that is installed on the client with NAP. So if the client wanna that NAP, they have to have a system health agent, SHA. And to be honest, SHA started by the first version of Windows XP Service Pack 3. So they have started the system health agent since that time. And when we say that agent is Windows XP Service Pack 3, if I want to use a pen here, then we have a client, and that client is linked to an app server, for example, or an app policy server. The server, they started the NAP policy or the NAP technology with Windows Server 2008 or later. So the server should be 8 or later. While the client, it could be XP Service Pack 3 or Vista or Windows 7 or Windows Server 2008 as well or later. So the clients, sometimes students are misunderstood how we have two versions, because we have clients and server. The server, they only have the NAP policy installed on Windows Server 2008 and later, while in agent base, we can install that on XP with Service Pack 3 or Vista or 7 or 10 now, or server or any kind of Windows server after 2008 or later. So this is the agent. This is the first component. The second, third parties can develop their own. Yes, in some scenarios, in some network, the third party who are using these two kind of NAPs, who they are using the agent and the server, can write a piece of code to develop a third party. So this is the first component, which is the agent or the system health agent. They are always using system health in NAP. Even the server, they are called NAP health policy server, right? So the second part or the second component is the system health validator. And that system health validator, which means the policy, the validation policy that should be installed either on the enforcement point, and it should be also mentioned, or it should be also defined in the NAP server. So these system health validator are installed on the network policy server component, and it's also can work with Radius, of course, as enforcement point. So this is the second part or the second component of the NAP component. The third one, which is optional, is the remediation server. The remediation server means a temporary network here, and this network are only used after the health check to get updates or to perform some kinds of administration work in order to guarantee that all the policy will be examined later and pass the health check, right? So this is like the quarantine network inside the network access control, but mainly here the remediation server means that you have some kind of access in order to let you update the conditions that you want to meet in the health check, right? So this is the remediation server. Again, this is the client. If the client, and this is the client Aruba, which I mean that client should have Windows XP Service Pack 3 or later. And the NAP server here inside, let's say the gateway here, the NAP server should be Windows 2008 or later. So if the client does not support any kind of NAP, it will be immediately forwarded to the guest network. Otherwise, if that client supports the NAP policy and it has a NAP agent installed on that client, while that NAP is not updated, or that client failed the health check because of the antivirus is not installed, or the antivirus which is installed is not the one that I want to all the client use it inside my network, or the firewall on that client is not enabled, then I can forward these clients to a remediation network where they can update the antivirus, do some network administration stuff in order to meet all the requirements that the NAP server or the NAP policy defines. So here we have the third option where the NAP server or the NAP client meet the requirement of the NAP server, and then all of these servers, all of these clients can use the real network inside my institution or the production network, which means they have a full access to all my network, right? In the DHCP enforcement point, again, if the clients are compliant, they have the full access. If non-compliant clients, they get a limited IP configuration. They can add some routing access to the routing table, but they can't have a full routing inside my network. Also, if DHCP enforcement is the only enforcement point exists in the network, it also can be hacked and can be, let's say, can be broken by some user who has, let's say, good knowledge in IT. Then they can define their own IP and they can pass by that enforcement point. So if DHCP is only the enforcement points used, some of the clients, they can define the IP address manually, and I guess IT people can easily do that and jump into the real network. So we should use DHCP enforcement points with other protection technique as well. And in this, let's say, diagram, you can see that the client who has the agent or the SHA and the NAP client, they send the SOH, which is the health check of the client to the NAP server, and here is the NAP enforcement point. One of these enforcement points, DHCP, or even a VPN 802.1x, and any other enforcement point. So the NAP client will send the health check, and I forget SOH means, I guess it's status of health, I guess something like this, yes. And they send it to the NAP health policy server, and then the NAP health policy server, who has the validators, can guarantee the access and can check the authentication and allow the Active Directory also to give you the name and so on, and define in which group policy will be used. And if you can see here, we do have a hop-to-hop connection, while at the end we will get endpoint to endpoint connection between the client and the server through the enforcement point. Here is a definition for VPN in case of you don't know VPN, but I've seen that most of you does know what does VPN connection mean. So VPN connection is a remote access connection from a client to the internet, can be anything using dial-up, a cable, and so on. So again, it's mainly a client to a private network can get that access to that network through the public network, which is the internet, via one of the mechanism of virtual private network. One of them, and the main one of them, is tunneling. Tunneling means they encrypt all the packets and they feel it like there's a virtual tunnel between the private network that you want to use and get that access among the public network. Again, here's the client, and we have the system health agent. And if that system health agent pass the network, the network enforcement point, then it can be forwarded to the network server point. If that client support NAP does not pass the health check, it can be forwarded to the remediation, and otherwise it will be rejected from any kind of accessing to the network. And here are the main components, the client and the server, that we could have it inside the network. We have a system health agent on the server. We have a quarantine agent in other kind of protection. We have enforcement client, that the client has the ability to be enforced in one of these health check. And on the server side, we have remediation server, network access device server, system health server, and network policy server. And the main important is to have in the network policy server the SHV, which is the system health validator that can guarantee the full access of that client. Here's also an example of IP security, as a figure about IP security, as we explained IP security as one of the enforcement points. So IP security, it has two components. The first one is called encapsulation security payload, and in the second part, something called authentication header. But I just want to simplify that by saying, if you have a hello message, and that hello message, you want to send it to the other end. So you have to have authentication. Authentication means you have to sign that message by X. So we know now that X has sent that message. And also we need to encrypt that message by the encapsulation. So we'll send by hello, or instead of hello, ABC something. ABCCO, for example, and that's signed by X. So we have authentication and encryption in the same packet. While sending that to the network, only the proper network with the secret keys, they can understand that that message is hello and it's sent from X. So this is basically the simple idea of IP security, is to send all the communication inside the network, all the packets transferred inside the network, encrypted and authenticated. So I guess that's all, guys, regarding network access protection. See you, bye.